Hi, Ashish, good morning.
Hello everyone, good morning. Okay, people are joining. Let me also connect. I'm not connected fully actually. Okay. What is happening with my system? So can you please help me out, like where were we previously with this module? I can remember we have completed not fully actually. MongoDB axioms. Oh. Have we covered the PMF and CDF? Please don't tell me you guys also forgot. So I think two more till this module 9 you have probability and statistics, and from module 10 you have data visualization with different kind of plots and all. So we were in between somewhere actually. Session 15 or session 16?
Actually, we saw probabilities second session, sir. In that probability, we have two classes.
Okay,
After
okay.
that,
No,
we
no.
have to see.
So have we? Can you recollect this total probability theorem and Bayes theorem?
Yeah, yes, sir. Yes, sir. We saw that.
And
yeah,
what
we
about
also done with that Bernoulli binomial. We have to see that geometric, I think.
Bernoulli binomial also done?
Yeah.
How come geometric got left? I think geometric we covered, right? If you recollect the fast success from all your trial. If you recollect geometric distribution, right? Okay, I got it. Okay, I can recollect now. Because like 2-3 batches are going on in the same module 7, 8, and 9. So I'm getting confused which discrete continuous. I think this is the file. And here, let me see. Bernoulli, we went. Why it is like, okay, it's loading. Properties of expectations, linearity, I think this one we covered. Constant scaling, variance. Guys, variance. Have we covered variance?
No, I think.
I think this.
No, Ashish, variance.
Yeah.
Variance was not covered, I'm saying.
So I think this properties of expectations we covered, right?
Yes, sir.
Yeah, that we covered.
I can remember few questions from Dinesh on this. Correct. Okay. So I think this gambling thing also we saw, right? Yeah. Okay. Now from variance, I think. Yeah. Correct. So if it is variance, then I think we are in. Okay, this one, right? Session 16. This simulating. So we are going to see some code here today. Hopefully. Okay, so 15. Great. And also I got one interesting question from my weekend session batch. So I was going through this this topic only. This module 8, 7, 8, 9. Actually 7, 8, 9, not 7. Module 8 and 9, if you see, 4 sessions are there, and these are statistics and probability. So most people don't find this interesting, or they're like saying like, okay, this is a theoretical, whether you were going to use this kind of question also came in this weekend session. I know you guys also thinking like whether it is going to be probability, statistics, mathematics. So consider, let's consider like this, in this way. Let's try to interpret it like if you are planning to go for a DS role, for that your brain needs some exercise to understand few concept tweaks, new concepts. So the point is here, once you complete all this module, not missing any single module or any single session, that will make your brain adapted to the DS kind of role, kind of exercise. So these are not like your, so if you think it, I'll also tell you like how you can. Now suppose you are running a product, you're working for a product where you want to know what is the distribution of your age, of like the people, those who are using that product, what is the distribution of their age, right? So if you don't have the statistical and probabilistic knowledge, then it will be difficult for you to grasp this. Like suppose you have multiple products from Amazon and you want to know and which age group is the frequently buyers of that product, from which to which age group, what is the range of group where most people are buying this product, what type of product. So these are statistical decisions. If you don't know the statistics, probability, then you may be not. So that's why it's a brain exercise. Don't think like where I can use or it will be beneficial or not, but yeah, the concept is you need to understand. That's what. And after learning this, also we'll try to simulate this in NumPy or code, so that you can also implement this immediately in your work environment. And that's up to you how you are going, but let's see. So we actually will left with variance. Now, if you let me recap the session for you. Let me first recap myself what we have. Yeah, so discrete distribution, right? Discrete distribution and continuous distribution. Right? This is what, hold on. After variance, we have continuous distribution. What is discrete distribution? That you already seen, right? Now in discrete distribution, what means by variance is a very important term here in statistics. It is a measure, like what is the example I gave you, which range to which range of age of people, those who are using the product. So here we are, if you think deeply, we are seeing the variance here. Like what is the variance of age group? From this group to this group, the product is being used, right? So this is variance. If you see in probability and statistics, variance is a measure of how spread out a set of data is. Now suppose you have people, a column in your data frame, a column where the column contains the age of the people. Now what do we mean by variance? Like from which to which age group most of my people or users or customers are falling into, like which get, suppose from 25 to 40, that is the range where most of your, like 90% of your buyer are buying your product. So we are seeing how spread out the set of data is there inside your data set. And variance formula will be also simple. So let me use my pen, 1 second, my e-writer. So here, working, yeah. If you see this mathematical expression here, okay, here two concepts. Two concept means sample and population. Okay, sample and population. What is sample? What is population? So consider population is the bigger thing, and sample is a just some sample or subset of that population data. Consider this is the age group of whole country, India. Okay, and sample is you are specific to a certain state data. Okay, this is the age group of one state. Now this is called what? Population. This is called sample. Very simple here. If you are taking another sample from this one, this is another, this is two states. This is also one type of sample. But here you need to understand, this is the bigger part is population, the smaller subset of data or the sample is called, that's why it's called sample. Now there is one difference here in the formula. If you see, if you see here, everything is same. Let me tell you, you guys understand this symbol? Those who are not from mathematical background, can they able to see, can they able to understand this symbol? What the symbol means? Am I audible, right? It's not disconnected.
Yes, sir.
Summation.
Summation, right? This means what? This means that the terms that you are going to write after this is to be summation. That means if this is the term, if you expand this, this will be something plus something plus something plus something, right? That. So in mathematics, instead of writing this sum, what they do, they have some symbol here. This is called summation symbol. This means what? Whatever you are going to put inside, this is going to sum. Okay. And also in if you do the same thing, but instead of plus you have multiplication, then how is the sign change? Like this. Okay, this is the sign for product. This is the sign for summation. Okay. Now here if you see summation of xi minus mean. What is xi? I've already written here, okay, but can you try to understand what is xi?
The values, elements in the data.
Data set, correct, correct. So that means if a column you have which contain age of people, here location of people, here any other details. But suppose you are considering one column where you have age of people, right? So suppose you have five people age, right? So now this xi means it will, the I, if you see here, this means I will vary from 1 to n. If I have 5 data set, that means this n equal to 5 points. So 5 persons data I have, the age I have. So this is my x1, this is my x2, this is my x3, this is my x4, this is my x5. Okay, and this means what? You do x1 minus mean square plus x2 minus mean, I am writing mu, okay, square plus x3 minus mu square plus, like this you have to write till what? X5, because you have 5. So this means this whole terms. Okay, so simplifying to write it in a simple way, you use this summation xi minus mean square. That means I is a variable which will vary from 1 to the data points you have. In this particular example, we have 5. So I will vary from 1 to 5. Okay, so this is the formula for variance. Now, if you see, if you will try to think in another way, another dimension, if you see, that means what we are doing, we are first calculating the mean of my data. How to calculate a mean?
Average of the data.
Right. So summation divide. So in this case, what? x1 plus x2 plus x3 plus x4 plus x5 divided by 5. That is my mean value. Now, once you calculate the mean, then if you see what we are doing here to calculate the variance, we are subtracting the mean from every data point, isn't it? Every data point we are subtracting the mean, then we are doing the square. Now, if you see this, by subtracting the mean, we are actually verifying this data point, this data point, this data point, is how much distance from mean. That's what we are calculating here. That's why it is, if you see here, variance is a measure of how spread out your data set, out a set of data is. That means how far this point is from mean, how far this point is from mean, how far this point. So every point we are seeing the differences and we are calculating. So this is called variance. How spread out. So variance and mean. So if you see any mathematical data you have or numerical data you have, people will ask about what is the average salary, what is the average income.
Ashish, can you please repeat the mean thing?
Mean means
Yeah.
average. How you calculate mean of something. Something, if I have age, 5 people's age, that is x1, x2, x3, x4, x5, how to calculate the mean? X1 plus x2 plus x3 plus x4 plus x5 divided by 5. This is how we calculate average, right?
Yes.
So this is average. Mean is nothing but average. Yeah. Got it, right?
Yes, Ashish.
Okay. Don't hesitate to ask these questions, guys, because I know, but these are, fundamental thing that you need to understand, even if you are seeing for the first time. So this upper part is clear. This is same in both sample and population. First of all, sample and population concept is clear, right? But here, if you see bit of difference, upper part is same in both the thing, but in lower part it is different. In sample, you have to divide n minus 1. What is n minus 1? Here, what is n in our example? N equal to 5. So n minus 1 will be 4. If this is a sample data, then you have to divide with 4. If this is a population data, then you have to divide with 5. And this is also, and guys, whatever we are seeing now, these are topics from statistics and mathematics. People are spending their life by doing PhD on this. Okay, so this is not small things. So, but we are trying to get the gist out of their thing and trying to show you here. Okay, so here this is actually proof why this is n minus 1 and what is, like, we are not going to that proof because we don't have that much time. Okay, but yeah, you need to understand, when you go for a sample, that means what? Subset of the data, you always divide with n minus 1. So this is called degree of freedom. We'll come to that part, what is degree of freedom. Because of the degree of freedom, sample data will be always minus 1. And this has the mathematical statistical proof also. Research papers are there, they proved why we need to divide n minus 1 in sample and why in population you have to divide only n. But the main concept is both are variance, and this will tell you how your data is spread out. Now, mean and variance, these are two important concepts in statistics, and this is where you need to focus. If you have a numerical data, you have to understand your variance and mean, because as I told you, the example, right, that product example, you have to say, okay, this is the average age of the users, those who are using product 1. This is the average age of users. So you will get an idea. Okay, while if you are a product owner, you will get idea, okay, like 25 to 35 people is the average age that people are using this product. So we'll make our modification in the product according to that age group. So this kind of decision will come from this analysis, isn't it?
Yeah, excuse me, sir. But how
Yeah.
can we know whether it is in sample or population data?
Yeah, you'll get to know. That will be given to you.
Okay.
So that will be
But with
given
the
to you.
question.
Huh. So
The simple answer would be the greater number would be the population and the smaller number will be the sample.
yes, but the thing is, like, sample population is kind of, it is considered as the heavy amount of data. It is not like small amount of data. So as I said, the example, the whole country data. Now you don't want to access whole country data and start processing and analyzing. It will take days and months, right? So instead of that, what you do? So why we take sample? Because you don't want to go for population data. Population data is huge. Okay, so instead of And also one more thing. Okay, I forgot actually. One more thing here. If you are going for any company or any kind of interview or anything, they will understand your logic behind using the resources. If you have more data and you are using that data and doing your analysis in computer, that means you are using more resources. If you do some mathematical computation also, that is consuming the resources in your system. And companies are running and paying for the resources they are using. So the less resources you are going to use, then it will be more beneficial for the company. So that's why instead of going for the whole population data and consuming more resources, you can take a small sample or few samples from the population and do your analysis. We'll see how this is going to help us. Because, okay, there is a funny example actually, guys. So if you, so this is sample and population. There is a funny example. If you want to see the tiger, then if you don't have the tiger, then show me the cat. This is what the logic is here. So you don't want to play with tiger, so you play with cat and do your analysis. But they will look like maybe size is smaller. So if my population distribution data looks something like this, I need to make sure my sample data should also look like this, but smaller. So that whatever analysis I will do, if these are same similar kind of thing, only the size and the data amount is different. So whatever analysis I will get from here, I can say the same thing about the population data. So I'll do my experimentation on cat. I will measure like the head size or anything. I can also the tiger also have this kind of head size, but with a bigger size. But the size or the shape is quite similar. This is the concept. And that's why you need sample data. So this is the sample. So we have actually sample versus population discussion that we already did now. So that I hope this is now clear, sample versus population.
Yes, sir.
Okay. Okay. Now what we have, okay. Now let's try to understand with one example. Okay. You have 20 students in your class and their test scores are like this. However, you want to know how much the score vary from the mean. How to know this? If I'll put this in my formula, what we mean by you want to know how much the scores vary from the mean. That means what you are asking? Variance. Now tell me what is how to calculate the mean of this data?
Total numbers divided by 20. Adding.
Divided by 20. Right, so 65 plus 70 plus 72, 75 till 100 you need to add and divide by 20. That will give you your mu. Now tell me how to calculate the variance here.
65 minus mu.
65 minus mu square plus
Minus
70 minus mu square plus like this. 72 minus mu square like this. Like this, like till 100 you go. Now divided by, this is a small set of data. So consider this as what? Sample or population?
sample.
Sample. So what will do? 20 minus.
Minus.
So this will be my variance for this data, whatever number I'll get. Now, if I have the variance, what that will tell me? How the data is varying, and we'll try to understand with diagram of the distribution. Don't worry. But till at this point, you try to understand variance means what? How the data is deviated from the mean value. So mean value means what? Like always the center value, right? Center value. How your data point? If suppose this is the scores here, right? And if you see here, I think the mean will fall 86, 88, 90, somewhere around 90 to 92. I'm not sure, I have to calculate, but somewhere around 90 to 92. Now 90 to 92 is your mean value. What other value have? 65 to 100. Like this. So this variance will tell how your data is varied, okay, from this mean. Suppose you can say Now, if this is 65, this is 100, and most of the data points are other data points are from 70 to 90. Okay, so you can say only few points are at 65 and 100, but 60% of my data are falling from first standard deviation or first variance from the mean. We'll see. Let's not make it complex. We have simple example to understand this thing. So the point is, once you have the variance, you have an understanding about your data, how this is varying. Now there is some properties of variance, like we have that properties of what? Additivity, that properties are there, right? That is property of what? If you recollect. Expectation. If forgot or what? So we have these properties, right? Properties of expectation, linearity, constant scaling, right? So same variance also has some properties. One of them is non-negativity. Now, first of all, this non-negativity will make sense whenever you see this formula, because the formula itself is a square, isn't it? So this value, the upper part, can't be negative, isn't it? So in the mathematics, so when you do some number square, whether it is negative number also, it will be positive. So from the mathematical itself, I can see one property, that this variance can't be negative anytime. This is mathematically. We have not we have not thought it in another way. What means by variance? That means the data points, how the data points are varying from mu, right? Whether how much distance from mu. Now, if you mathematically, negative is not possible. Let's try to understand in this way. If I can say this point is negative 5 times variable from mu, is that making sense? So that means this distance always a positive distance from mu. This is your variance, right? If I'm talking about this point and this point, this vary from mu with certain distance. Now this distance can't be negative, isn't it? Both way you try to understand. Mathematical also is not possible, and if this distance also matters or not, that is also can't be negative. So that's why one property is non-negativity. Okay, now zero variance. What do you mean by zero variance? If all the data points in a set are the same, the variance is zero. Now you tell me how I should draw this graph so that it will it's same as zero variance. When we say zero variance, what does that mean?
It means that all the points lie in the same point.
Right.
Output is 0.
So suppose I have one age group, that is 25. That's all. And all the people
are 25.
25. Okay, all the people's age are 25. So that means here there is no variance from mean, no other age group or data point present. Everyone's age is 25. So in this case, what is the variance?
Zero
is
variance.
0. And mathematically also you can prove, isn't it? Suppose you have 25 one people, 25 one people, 25 one people, like this. Now if we'll do the average, what will be the average?
100 by 425.
No, again 25.
Okay, so mu will be 25. Now you put it in the variance formula. Xi is 25 minus mu also 25 square, right? Plus again
So
another
0.
0.25. So everything will be 0. So variance is automatically 0. So this means what? This is again an analogical thought here. Variance means how spread out your data from mean.
It means you are saying that variance can be 0 but may not be negative.
Correct. Correct. So non-negativity is zero variance, understood. What is boundedness? the variance of set of data is always less than or equal to the square of the range of the data. The range of the data is the difference between the maximum and minimum values in the data set. For example, you have age group where you have 15, 16, 20, 25, 30. Suppose, let's take this age group. Now this is my data. What do you mean by boundedness? The variance.
Ages can be between 15 to 30, but not greater than 30 or less than 50.
Right. That means what? It will be always between maximum value to minimum value. The range of data. What is the range of this data? This means what? Maximum to, this is my range of data. This is also making sense, right? Because you are doing the square from the starting to the end point. So this is any query on this boundedness part? So Dinesh, are you there? Dinesh, you're not asking anything today. I think Dinesh is busy today. Okay. So guys, let's you understood, right? Boundedness. Now additivity. If x and y are two independent random variables, suppose age column you have, another column you have. What is that? Another what you can say, income. Okay, x and y are two independent random variables, then the variance of their sum is equal to sum of their variances. What does that mean? Variance of these two data together, age plus income. If I want to calculate this data variance plus this data variance, that means what? Variance of age, you calculate variance of age column, then you calculate variance of income column, then you add them. This will be a what? Variance of age and income, both. If you want to calculate for both of them. Additivity. Scale invariance. If a constant is multiplied to all the data points, that age group, or take this example of data. If you are going to multiply 5 in every data point, 5 into 65, 5 into 70, 5 into 72, 5 into 75, that means what? A constant you are multiplying in every data point. Then what happens to the variance? The variance
Will be also multiplied with the same.
Not with the same, by square of it.
Oh.
Because if you see the formula,
Yeah, formula it is square.
xi, this divided by n minus 1, right?
Yeah.
Here this part is multiplied with 5. If we will take this out of this bracket, it will be 5 square into xi minus mu square. Not here. Okay, like this. That means what? This part is multiplied with 5. Now here the variance will be square of that constant. Okay, this is called what? Scale invariance. Okay, so these are the properties of variance. Now the fun part begins. This is called, yeah.
Please repeat scale invariance.
Okay. So suppose you have 10, 12, 15, 20. Okay, this is your data, sample data, right? Now, if I'll do one thing, I will multiply 5. Okay, that means to every data point. What is that? 5 into 10, 12 into 5, 15 into 5, 20 into 5.
5.
So just a minute, my pen got closed. 20 into 5. So now this is my new data set. Now here the variance is V. According to scale invariance, it is telling you now the new variance will be 5 square into V. Previously it was V, suppose one number. Now if we'll multiply with a constant to all the data points, then the new variance will be 5 square into B. And this also you can prove mathematically. How? Now what is the variance formula? 5 into 10 minus mu square plus 12 into 5 minus mu square plus, like this you have to do, isn't it?
Yes, sir.
Now if we will take 5 common, it will be 5 square, right? 10 minus mu by 5. Now just a minute, guys. Am I doing the wrong mathematics here? The variance is also multiplied by the square of that constant. This property is known as variance of the product. Now
So actually, I think the variance what we get is multiplied by the 5 into 5 square.
this is what you're saying, right?
Yeah.
No, mathematically I am saying so this
Sir,
is
if
not
we take 5
Hmm.
outside, means 5 as a common means,
Hmm.
in place of 10, there will be only 2, sir, I think.
No, not that too. If constant is multiplied to all the data points in a set, now suppose this was your data point, now you multiply.
So I got it. It is 5 mu. It is not 5 by mu by 5. It is 5 mu. 5 into mu.
Oh, right. So mean also will change, right? Correct.
Yeah.
Correct. So here, okay. So here the mean also will change. That is right, 5 mu, right? Right. So okay. Let me. Nice. Okay, I removed actually everything. So if you see here the mu will be 5 mu here, right? Correct. So if we'll take 5 common, then this 5 also come out. So this will be 10 minus mu plus 12 minus mu plus 15 minus mu, and that is equal to your what? V. So that's why it will be 5 square into V. Mathematically, if you want to prove this. Good. So I was taking 5. So that's why, like, why mathematics is totally different here. Okay, so
Actually, what happened is you directly multiplied with the data, not with the mu. That's why it is.
So the mu value will also change, right? That will be 5 mu. Okay, great. Nice. But you got now, right? Whoever, I forgot actually, whoever asked just.
Yes,
I think,
sir.
Okay, great. So let's just a minute. Let me clear this thing. Now the fun part begins is what is called your continuous distribution. Okay, now these are all about discrete distribution, isn't it? Like your dice, rolling dice, picking card. That means the data is not continuous. But what example I was giving to you, is the age data continuous data, guys?
No.
No, right?
Yes.
And what are the examples of continuous data?
Height, weight.
Right. IQ, or you can say your rain amount, or wealth distribution. That also, like, points we have, like this 100 point, this, right? That also. So continuous data means what? The data is continuously distributed. There is no break inside your data. Now, for example, if you in the x-axis you plot what? The weight of people. Now, weight of people usually for an adult, whether male or female, it will be from 30, right, guys? 30 to 100. Let's see. 30 to 100. And now if you see, if I'll measure a weight of a person, that will be any value between 30 to 10. But if we'll try to plot this graph, this data is not going to break, because at every point you have one person's height. right? So this continuous data plotting, like the data is not going to break for this weight, right? Like we have in a discrete, like this we have, right? Discrete. That means this is the dice probability of getting one number. This is probability of getting two number. This is probability of getting three number. So there is no continuity between your data. The data is discrete. But here what? The data is continuous. And at each point you will get some weight of the person. There is no break. So that's why it is called what? Continuous distribution. And this is where most of our example and you are going to encounter the real world problems, right? Continuous distribution. And there are three types of continuous distribution. Let me read that for you. In probability and statistics, a continuous distribution is a distribution that can take on any value on a continuous range rather than only taking on specific or distinct values. Okay, continuous distribution are often used to model variables that can take on a wide range of values. Like I said, right, that weight from this to this, such as measurement or quantities. Now, why we are learning this, all these things, that as I told you before, this is like a brain exercise for us. We need to know certain things and try to understand. If we try to understand that, then the DS field will be easier for us. Now, there are certain known distribution, continuous distribution, known. Three types of known we are going to see here. And we are going to study about this known distribution. Once you study about this known distribution, then whenever you have any real life data, continuous data, you can try to correlate with one of these three, because these are known distribution. And by knowing that your data is following one of this distribution, you can take important decision. Now, suppose one data has been given to you and you found that your data is following same properties as normal distribution or uniform distribution or any exponential distribution. That means what? You can directly say or take decision on your data based on this distribution's property that you are going to study. So this is the benefit. If you're thinking like, what is this, like why we're learning this? So by knowing the known distribution, you can take the appropriate decision. Now, three types: normal distribution, uniform distribution, and exponential distribution. These distributions are defined by their probability density function. So here, guys, in data science, we are going to study this as probability. That means what? That means what? If I am plotting the weight value in the x-axis, in the y-axis, I am going to plot what? The probability of getting that weight. So if some person is having this weight, suppose 50 kg, what is the probability that the person is 50 kg? Okay, it's not like the number of people. So usually what happens? If you have 1,000 people's data, you will calculate how many people are falling under 50 kg. Here, usually what you need to draw. Guys, let me make you clear one thing here. Bear my drawing actually. So if I usually don't consider probability. If I have 1,000 people's data and their weight is from 30 to 100. Okay, in the x-axis I kept what? 30, 35, then 40, like this till 100. And in the y-axis, what we used to do? How many people from 1,000 people are 30 kg? Suppose you have 2 people are here. In the 35, you have seen 4 people are here. So what is this 3 people, 4 people? What is this? The frequency of what? Of this weight. 30 kg, how many people are there? 35 kg, how many people are there? 100 kg, how many people are there? We are calculating the frequency. We used to plot in a normal scenario, we used to plot age and the frequency of the people is having that weight. But here in our case, we are not going to plot the frequency in the y-axis. We are going to plot the probability. What is the probability that people will have weight equal to 30? And that's why it is called what? Probability density function, PDF. So when we saw PDF in the discrete distribution, you can you recollect what that means? That means we are not plotting the frequency here. Rather than frequency, we are calculating the probability. What is the probability that this many people will have fall under 30 kg? This many people will fall under 35 kg. Okay, so not frequency, but probability. That's why it is called what? PDF, probability density function. What is the density or the frequency of probability? And this PDF will be different for different distribution. For normal distribution, this PDF will be different. Then uniform distribution, the PDF will be different. Okay, so PDF means nothing but two types of way you can understand this. One is visually, one in mathematical way. Now suppose I want to understand normal distribution, I'll do it in two ways. I will plot this normal distribution data and I'll see how it looks like. Also, I have mathematical formula for this distribution. So by two ways, you can quickly distinguish one distribution by seeing it mathematical formula, which is called what? PDF of the distribution, or the histogram, or by plotting it visually. Two ways, normal and uniform exponential. All these distribution have two ways of identification, quick identification. Okay, let's see the formula and all. Bear with me, guys. Let me know if you didn't understand anything, so that will stop, because we are going to go a bit mathematical here. Okay.
Sir, one question, like prior to this, you have told about many distributions like geometric and binomial. All those are varied for only discrete. Only from
Discrete,
now we
correct. Correct.
Okay.
Now, if you see there, we have not used any continuous data, cards, rolling dice, right? So those are not continuous data, those are discrete data. But here, so two types. Okay, two types. If you see try first understand what you are learning, then do it. Okay. So if you see here, first part is what? This part is on discrete distribution that we saw, Bernoulli, binomial, geometric. Okay, this session. But here, this session, this expectation is part of discrete, and then it is continuous distribution. Now we'll see all the thing about continuous distribution, which is, I think, a more frequently used in the industry. Continuous data, stock market, stock price prediction, right? So those are continuous data.
So the random variables PMF, CDF, and also are valid only for discrete, not continuous. You cannot define random variables for continuous distribution.
Yeah. So see, random variables, PMF and CDF, these are in every distribution. Now you tell me, what is random variable? Random variable is nothing but what I am plotting every time in x-axis. This is my random variable. So for discrete also you have random variable, for continuous also you have random variable, isn't it? So there, the random variable for the discrete distribution, the random variable x was for rolling a dice, it will be from 1 to 6.
1 to 6, yeah.
But here in the age or the weight I have told, that will be from 30 to 100. So these all are whatever we are plotting in x-axis, those are random variable.
Yeah, okay.
Nice. So this type of doubt also clarify most of the things for you. So I'm glad that you have this, because I also get confused, guys, when I started. Like, what is this? But I'm trying to make it easier for you so that you won't get confused in future. Okay, so two types of distribution, and every distribution, whether that is discrete or whether that is continuous, every distribution have their respective random variables, respective probability density function, But here in continuous, it is called probability density function, but it in discrete is called what? Probability mass function. Okay, and the CDF concept is also same for every distribution, cumulative distribution from the previous value. We'll see. So whenever you see PDF, so what happens? No, usually it was for me also. Whenever I heard PDF, I'll always remember the normal distribution. Okay, I thought like PDF will be used in normal distribution only, but actually PDF means what? Probability density function. So these are functions which normal distribution is a function, exponential distribution is a function. Okay, so these are actually functions, and each function has their own PDF in terms of mathematics, in terms of visualization. Now let's deep dive into what is, and this is a widely used, frequently used distribution in the industry, that is called normal distribution. And using this concept, we are going to prove some theorems also. Not today, I think, right? And the next session, yeah, CLT, central limit theorem. Using this normal distribution, we are going to see the theorem. Now let's try to understand the mathematics here. The normal distribution, also known as Gaussian distribution. Okay, so you may heard these terms also, Gaussian. Gaussian and normal both are same. It is a continuous probability distribution, not frequency, probability distribution, that is defined by a symmetric bell-shaped curve. So that is one learning you are getting from here about normal distribution. Now, if you see something like this, this means the data. If you plot your data, and you will see we'll see in the code also. Okay, we'll try to plot in the code and we'll try to visualize whether this type of shape is coming or not. But suppose you plot your data and the data is coming out of this shape. Okay, symmetric, but here not symmetric, guys, forget my drawing, but yeah, consider symmetric. Symmetric means what? This side and this side looks same, but here in my drawing it is not looking same. But yeah, symmetric bell-shaped curve. If your data, suppose you collected height of people and you plot that data and it is looking something like this, that means what you will understand? Your data is following a normal distribution. So this symmetric bell-shaped curve, this is the sign or this is the symbol for normal distribution. If you'll see this kind of plot, you blindly say this is normal distribution. That's why we're learning all this known distribution. It will make our it will make our life easier to take some decision, because you have been provided random data and you don't know which type of distribution your data is following. But once you started plotting your data, you got to know, oh, okay, it's looking like a bell-shaped curve. So that means what? This is a normal distribution. Now, whatever we are going to learn about this normal distribution, its properties, its formula, everything you can now apply to your own data set. Now let's try to find out. It is one of the most widely used distribution in statistics. True. And is often used to model variables that are approximately normally distributed, such as your IQ scores, height, weight, other measurements, like example of normal distribution they're giving. The normal distribution is defined by its mean, which is the average value of the distribution, and its standard deviation. Now here you are going to encounter this term called standard deviation, guys. Okay, please pay attention here. So standard deviation is nothing but, we have variance, right? So variance we write V, standard deviation we write sigma. This is sigma. Okay, and relationship between variance and sigma is this: standard deviation is root over of variance. This is the relationship between what? So standard deviation and variance. Now you guys understood variance, right? If I'll tell you this is the variance, can you calculate the standard deviation? Yes, by taking the root over. Or another way, variance equal to standard deviation square, isn't it? Okay, so this is also small catchy points that you need to keep in mind, because anyone can ask this type of question. What is variance? What is standard deviation? What you mean by standard deviation? Okay, now it's so which is the average value of distribution, and its standard deviation which describes the spread. Again guys, same thing, right? Variance also we have seen these terms. Describe the spread or dispersion of the distribution, isn't it? Okay, the mean and standard deviation completely describe the normal distributions and are used to compute probabilities for different value of random variables. That means those x-axis values, different probabilistic values. Now let's try to understand. So you need not to worry about this, guys. Okay, you need not to and remember or keep remembering these formulas. You need not to do that. Okay, let me clarify that also, because few people are thinking like, who is going to remember this? Because we need to know what is happening in the background. If someone will ask you, you need to be able to explain them. But in real life, you are not going to write this formula. In real life, what? You have Python. Okay, so whatever formula you are seeing, that is written inside a Python library. So maybe we are discussing for 2 hours, but if I show you the code, if I want to get the normal distribution, then I will just write one line of Python code. It's just a library which will do the same mathematical things here. We'll see that. That is called your simulating in NumPy. Whatever we are discussing, we are going to do it practically, but through codes. Okay, but you need to understand the concept. So that's why people think like, why this is required? Because if you don't know what is variance and you started using the code for variance, what does that mean? Does it make any sense? Someone will ask you what is happening in that variance. You said like, I don't know, I just use codes. Okay, I can't tell you. Okay, so that is not the case. You should not be like that. So that's why we are, going through all the mathematics and trying to understand what is the logic, what is happening. Now, as I told you, every distribution have their what? Probability density function, PDF, every distribution, whether that is discrete or continuous. In discrete, this is called probability mass function, because there is no density, that is an integer value, 1, 2, 3. That's why a probability mass function. But concept is every distribution is having one PDF and CDF, cumulative distribution function. What is the PDF of normal distribution? Now, if you see, if you recollect, in mathematics, we write y equal to f of x. What does this mean? Have anyone seen this before? Y equal to f of x. What does this mean? What is x? What is y? What is f?
Function of x.
Yes. What is x?
Element.
So x is an independent element. Okay, x is your independent element, and you are passing that independent element some kind of function, any kind of function. Either your function is a plus b, or your function is a into b, or some complex mathematics, or any kind of function. And once you put your independent variable inside this function, the output you are getting, this is called what? Dependent variable. So x is independent. You put something in some function, and whatever value you will get, that is your y. Now, how to draw this y equal to f of x in a graph? Tell me how to draw this y equal to f of x in a graph. And my drawing is really miserable, guys. Please let me try to draw. This is my x-axis, this is my y-axis. How I am going to plot y equal to f of x? First of all, x-axis values I will put here. Okay, so suppose x1 I put x1. Then whatever I will get after this function, that is my y value, and in the y-axis I will plot that. This is first point. Suppose y is coming around here. Then x2, then y2. x3, y3. Like this, I will plot my y equal to f of x. This is a generic form, right? For any kind of function, you want to try to plot that graph, you take x, you calculate by calculating, putting that x into the function and get the output. Then you give that value in y-axis, then you plot. So PDF is nothing but this kind of analogy only. This kind of analogy after you taking x and calculating. So here this, what is y in this equation? The output of this calculation.
F of x.
Okay, so y is nothing but, if you see f of x mu and sigma. What is this mu and sigma? That means here mu means mean, sigma means standard deviation of your data. X is independent variable. This is your f of x. Same here. And this is your y. That means once you pass this x inside a function, so this is my function. Here it is a function is exponential function, e to the power. Exp means what? E to the power something. Now, when you are trying to calling a Python library which will help with normal distribution, this is happening in the background. Okay, it is calling a exponential function. Now, if you want to plot, then you try to get x1, x2, any number from your data set, and you put inside this formula. Whatever value you get, then you plot x1, then that respective y value that you got. x2, then that respective y value that got. Like this you plot, and this is your what? Probability density function. In
So
a
there is a
layman
bar,
term.
right? After x, f of x slash is there.
Okay. No, I have not come to this explanation. I'll come now. So
Okay.
this is a generic explanation I'm giving to you. Now, particularly if you come this here, this is f of x. Here, this means these are also two variables. What? Mu and sigma. And mu and sigma is what?
Standard deviation.
Standard deviation.
Mu is mean, sigma is equal to standard deviation. Okay. So if you have your data, you can calculate these two terms, isn't it? And this is the formula. What? 1 by sigma into root over of 2 pi. This is the mathematical formula of normal distribution, that f of x. This is this f part. Okay. E to the power minus 1 by 2 x minus mu by sigma square. This is the mathematical formula. And this E is written as exp. That means e to the power. Now, what is E and all? I think that is different thing, right? Those who, anyone who doesn't know what is E, what is the value of E?
2.71828
Yeah, so it has some, correct. So this has some specific value. Now, using this exponential function, this normal distribution is calculated. Okay, let me clear this. Now, what is x? X is the value of the random variable. Consider that x-axis values. Okay, this is x. With different x-axis values, we are going to put different values here, and we'll calculate what is the total. By putting x, different x, we'll calculate the whole term, and then we'll plot it. Mu is the mean, s is the standard deviation. I think this part is clear. Yeah, any question?
Here we are
Okay.
calculating the X for mean and standard deviation in the left side part, is it right?
So this is the way to writing this mathematical equation. That means this mathematical equation is combination of three parameters. Which three parameters? One is X, one is mu, one is sigma.
Okay.
That means this mathematical expression is a combination of X, mu, and sigma. Isn't it? So
Okay.
that's what it is written there. So the function is the combination of X, mu, and sigma, where X is random variable, mu is mean, and sigma is standard deviation. And here exp. So whenever you see exp something, exp p, what does that mean? E to the power p. Okay, that's why exp whatever in the bracket is e to the power, then whatever you are writing here. Okay, that's what expx.
So it means that the bell-shaped curve is for that probability continuous distribution.
Correct.
And for function of this is that 1 by sigma into 2 root of
Correct,
2 pi
correct.
exponential.
Correct. That means I told you two ways of interpretation, right? One is this way by so if you see your mathematical equation looks something like this, or you plot that and see this is how it plotted. So in by two way, either this way or this way, you can blindly say this is normal distribution.
Normal distribution. Okay. Oh, so this is PDF, probability density also.
Probability density function. This is called probability density function of normal distribution, this part.
Okay.
Okay, so this is the use cases, and unless you will know these things, it is not going to be interested, to be honest with you guys. Okay, if we'll try to read these things from online resources, you will get bored. Okay, so many things and not getting, so this kind of thing will come. But yeah, and this also, the explanation I am also giving it to you, it is getting refined day by day as I'm taking the sessions. So that's why so these are theoretical questions, guys. Okay, and I hope now you will be able to explain to someone, because that is important. Now this is how it looks. Okay, I borrowed this from, I think, Wikipedia. Yes, Wikipedia. If you see this, this is how a normal distribution PDF looks like in terms of visualization.
Symmetrical bell-shaped curve.
Okay, and this is the widely used distribution because it will help you to analyze your data very quickly, fraction of seconds or within few seconds. So those, suppose if you see here, I'm not going to explain more detail, but one example I'm going to give you. I can, by looking my data, if my data is following like this, I can immediately say 69 or 68.2% of my data is between this point and this point. So that means I can say, if I collected the weight of people for my one product, I can say 68% of my customers are from this weight to this weight. Now, how I am saying this 68% to exactly? That is a very particular exact value, isn't it? You can't be so sure about saying something like 68.2% of my whole customer is between 15 kg to 20 kg. That means this two value I'm saying. So these are like, this is the benefit of knowing the known distribution. If you have some unknown data provided to you and you explore it and you found that your data is following this type of distribution, then you can immediately say 68.2% of the data is falling between this range to this range. Or I can say 97% of my data is falling between this range to this range. That means mu. Okay, guys, here if you see, this is a mu, and if you see what is the next point, mu plus sigma, it is mu minus sigma. This is called first standard deviation. Now suppose if mu is 10 and sigma is what, 1, then what is the range? 9 to 11. So 9 to 11, I can say between 9 to 11, if this is my 10 and sigma is equal to 1, I can say from 9 to 11 weight, I have 68.2% of my customer. That is called 68. So in the other way, I can say 68.2% of my customer are falling between first standard deviation. Mu minus sigma to mu plus sigma. This is first standard deviation. Now, if you see here, 36, 36, 26, so around 97. Okay, 97% of my customer are between this range. That is your second standard deviation. That is mu minus 2 sigma. See here. Here we are doing mu 1 sigma. Here 2 sigma, 3 sigma. That means what? First standard deviation. Within second standard deviation. Within, this is my third standard deviation. So within second standard deviation, I have 97% of my all customer. Okay, so this kind of analysis you will be able to do once you know about normal distribution and about your data. Okay, so this is the benefit of getting your known distribution and understand your analysis. Now, if you see PDF and CDF, we have already seen the PDF. In probability and statistics, the probability density function of a continuous random variable is a function that describes the relative likelihood of the variable to take on a given value. That frequency example I have given you, right? Instead of frequency, what we are going to get? Relative likelihood. Likelihood means what? That probability, isn't it? We have seen this in conditional probability. That means here we are not calculating the frequency of occurring. Suppose 30 to 35 kg in this range, how many people know? What is the probability of getting maximum people in this range? Not the frequency. That's why it is called what? Relative likelihood. Okay. And if you want to calculate the PDF in a particular range, what does that mean? Now you have the function, right? Now this is bit of, I don't want to explain this to you. Maybe this is going to, difficult for you. Those who are from mathematics background, they know this is what? What is this called, guys? What is this f of x dx? Anyone knows?
Limit from A to B.
Yeah, but this is called what? Integration. Okay, integration limit from A to B. You are correct by saying limit. That means you know these things previously. So those who are totally new and not from mathematical background, you can say this is, we're not going to discuss this much. Okay, don't worry. So this is just to showcase that this is what happens. If you want to understand the PDF in certain range, you integrate or take integration help to do that function called f of x dx. And here x will vary from A to B. Now it is depends on the function how you do the integration. Let's not go to the integration part. That is purely mathematics. Okay. And I am glad actually when I saw these things, because I was also wondering from my college life, we are studying this much mathematics, integration, derivative, trigonometry. Where we are utilizing this? But when I saw this for the first time, I'm very glad. Okay, somewhere we are utilizing the mathematics that we have studied, right? This integration and all. But here we are not doing it ourselves. Already the course is being implemented. You can directly call the library and this will calculate all the mathematics for you. Whatever we see, PDF, equation and all those things. Okay, we'll jump to that coding part. So this means what? The interval between that point, you do the integration and you find that. Now, how this CDF? I told you, right? what is CDF in our discrete distribution? Cumulative. Cumulative means what? If you are considering at this point, what is the probability? If you'll do CDF, that means you consider all the previous points probability also. Cumulatively, you calculate. Now, every point I calculate CDF, this will be cumulation from the previous point. Now, can you tell me one question? If I am calculating the probability, then at the last point, at the last, very last point here, what is this value? If we are doing the cumulation of the previous probabilities, because one event to be occurred, what is the total probability of one event to be occurred? 1. And at each point we are calculating the probability, and in the next point we are doing cumulative. Then at the last point, what should be the probability? If this point is having 0.3 probability, if this point is having, so how this is working? Cumulation. If this point is having 0.2, then how the CDA plot? Okay, let me, because these are
All probability.
sorry.
While adding the all probabilities, what we have.
Correct.
It.
So when you add all probabilities, then that will be 1, right? Because probability will be, maximum value is what? 1. The axioms, the accepted truth, you recollect that part? It will be between 0 to 1 probability always, isn't it? So if I am doing Q, so suppose this x1, so this is x1, this is x2, this is x3, this is x4. Okay, here the probability is 0.1. Here the probability is 0.2. But when we do CDF, that means here the probability will be 0.2 plus 0.1. That means what? 0.3. Now suppose at x3 the probability is 0.2 again. Then how this will be added? 0.1 plus 0.2 plus 0. So this will be 0.5 like this. So cumulatively it is growing. So at the end, what you will get? 0.5 plus rest of the probability, that means 1. That means at the end, this curve will be like this. Because cumulatively, if you keep adding all the probabilities, eventually it will end up at 1 only. Maybe it will different at different points, but CDF means we are cumulatively keep adding the probabilities. This is what CDF is. Okay. Now, if you see how to calculate CDF of this normal distribution, same concept. Probability x less than equal to s. Right? If you recollect our CDF of the discrete function, same way. And if we'll integrate this equation from -infinity to x, or the value that you need, this will give you the CDF. Now you need not to do all these things. Okay, this is just for your knowledge how the CDF and PDF is getting calculated. CDF is what? The integration from -infinity to x. You need not to worry about it. Okay, you need not to go to this mathematics integration and all. Just try to understand there is some certain things that if you perform mathematically, it will eventually get you the CDF. That's what you need to understand. As I told you here, right? This is the graph of what? CDF. And every point the probability is getting added up, and at the last it is reaching to what? 1. And this is the graph of what? PDF. PDF of normal distribution. This is the graph of CDF of normal distribution. Now this is all about normal distribution. Let's try to see another type of distribution. 3 we have, right? Normal, uniform, and exponential. So we somehow, it is not done yet. We are going to use this normal distribution concept in our next sessions. Okay, so this is not done yet. So I hope you got some understanding about normal distribution. Now let's see another type of distribution is called exponential distribution. Now what is the benefit of this one? Now suppose again you have given some unknown data and you plot that data. Now exponential distribution will look something like this. There it was bell-shaped curve. Here it will look something like this. If we'll plot the x and y, it will look something like this. That means what? Oh, we'll come to here, okay, how this is getting done and how, like, which real life data is there with exponential. We'll come to this point, but the difference is what? If we'll plot x and y, it will be in this way, in like it will look something like this. So whenever you see your data is looking something like this, you can immediately say this data is following exponential distribution. Okay, just 1 minute, let me give the charge. Right, now let's try to understand in detail. The exponential distribution is a probability distribution that describes the time between events in a Poisson process. So let's not go to the Poisson process. Okay, that is a so what do we mean by Poisson process? The basic example here is your radioactive decay. Probability distribution that describes the time between events. Consider this data as your laptop. Consider your laptop. From the day you bought the laptop until now, the performance of the laptop is decreasing or increasing? From the day one you bought until now, till date. Decreasing. Consider this data, performance versus time. Like in the x-axis you take time, in the y-axis you take the performance. How it will look like? If you consider in x-axis you have time. When the time grows, the performance will decrease. And at one time your laptop will be too old that you will not use it. So this is one type of example. There we have example what? IQ, weight, height. Those will follow normal distribution. But this kind of data, decaying, or if you plot the time interval and the customer care calls that a customer care center is getting, number of calls with respect to time. Initially in the peak hour of the day it will be higher, and gradually it will decrease towards the end of the day. So here exponential distribution, one good thing about it is you are sure that it is based on time. That means with increase a time, whether your data is increasing or decreasing. Okay, and constant average rate it is happening. So the decaying which is happening of your laptop's performance, that is happening in a constant way. That is changing in a constant way with respect to the time. This is one example. Okay, it is not like all the example you will correlate with this example, but one of the example like height, weight, we have normal distribution here. Radioactive decay. What is radioactive decay? That uranium and those, if you plot those details in a plot, so the radioactive substance are decaying day by day. That is one example. I think we have other example also. Let me see in the time between failures of a machine or other piece of equipment. Time between request for service in a computer system. Time between radioactive decay. Time between earthquakes in a particular region. If we try to plot this data, it will look something like this. Okay, and what is the benefit of learning this? because once we know the properties like we did for normal distribution, right? Here we saw this to this percentage, this is the mean value, this is the standard deviation value. Okay, like this, if you'll understand about exponential distribution, you can answer few of the questions of your unknown data. Now, PDF of exponential distribution is very simple here. If you can see, PDF of exponential distribution, what? Lambda into e to the power minus lambda x. This is the mathematical way. So two ways, mathematical way, visual way, right? This is the mathematical way. What is the visual way? This is the visual way. Okay, now let's try to understand the mathematics here. Where is the mathematics? F of x equal to lambda into e to the power minus lambda x. Now, what is x here? Time between the events. That means you're consider that a service request to a call center, right? So you got one request at this time, then another request in this after this time, after 2 minutes or 3 minutes, another request in another 3 requests in the next 3 minutes. So x means what? That 2 minutes, 3 minutes, like this, the time between the events. And here lambda is called the rate parameter. Now, what is the rate parameter? Which is the inverse of the mean time between the events. Now, can you tell me what is the unit of lambda? If lambda is the inverse of the mean time between the events, what is the unit of lambda?
Seconds.
Unit between inverse of mean time. So when I say inverse means what? 1 by second. Okay, so here the unit is what? Second to the power minus 1. Isn't it? That's what 1 by something means, right? If I say 1 by a, what does that mean? A to the power minus 1. So when I say inverse of the mean time, that means 1 by time, suppose second, 1 by second. So the unit, so whenever you see something per second, that means what? That is the rate parameter. How we can easily identify rate parameter from the mathematical question given to you. So you see the unit. If it is 1 by second or second to the power minus 1 or
No,
t
it
to the
will be
power
like
minus
0.11, 0.001.
yeah, but you need to be mentioned. That is the numerical value. Unit also need to be mentioned, right? When you say 0.111, what is 0.1? 0.111 per second. If this is
Yes.
written,
Yeah.
that is your rate parameter. It is a, let me clear this. It is a positive real number that determines the shape of this distribution. And that is also making sense, right? If you change the lambda, then the distribution of the curve will change, right? Like this. So this means what? If you change, like this determines the larger value of the lambda, the smaller the mean time between the events. That means what? Lambda is 1 by time. This is what is said, inverse of time. Now, larger value of lambda, the smaller value of the mean time of the event, right? So if this is larger, that means what? This is smaller. If this is smaller, this means this is larger, inverse. So this means once lambda is inversely proportional to time. And based on this lambda, your curve or the plot will also change. We'll see that in the below diagram. The larger the value of lambda, the smaller the mean time. The mean of the exponential distribution is, now here if you understand this is your lambda, or this is your data is following a exponential distribution, and you got the rate parameter, then immediately you can say the mean of your data that you have currently is 1 by lambda. That's why we are learning this known distribution, so that when we identify our data set is following one of this distribution, we can immediately say, okay, 1 by lambda is the mean value. You need not to calculate the mean value separately. Standard deviation is also 1 by lambda. Okay, so suppose you identified your data that you currently have is following exponential distribution. What is the mean of your data? That is 1 by lambda. What is the standard deviation of your data? 1 by lambda. So this is why we're learning this known distribution. Okay. Okay. So the exponential.
Excuse me, sir. How do we know from the questions or the what we are given the data
How to know?
that we are trying to calculate those things, right?
Mean and standard deviation.
That's we can calculate that here we are calculating the time and the time based events.
Time based. Correct. Yeah, I got your point. So how you need to calculate time based events? We'll see with the example. We'll see. Okay, so we'll solve one question that there I think you will get better understand this. Okay.
Okay.
So,
okay, sir.
So just you need to keep in mind what is, if you have this equation with you, you understood this is exponential distribution, and if this is exponential distribution, the mean value, if you know what is lambda, the mean of your distribution is 1 by lambda. The standard deviation is also 1 by lambda. This you need to keep in mind if your data set is following what? Standard deviation.
So in this job, so with this formula and with the use of codings, we have to provide the graph.
Correct. You can provide the graph also. So that depends on what problem you are solving.
So I thought that we can directly solve by looking at the graph, but now only I understand we have to create the graph.
Yes. So different distribution have different analogy, right? So few of them you can solve by graph. For few of them, the mathematical equation. So I did two way, right? Either you see mathematical equation or you see graph, which is feasible to you.
Okay.
Yeah, visual interpretation is always a champ actually, because that's why the data science field is getting popularity now. Even I'm not sure whether you guys are aware or not. Again, the data scientist job also in risk due to this AI, because these things AI can do very quickly. So I'm not sure, because this is very dynamic period, guys. I don't also know what is happening. I got to know this news like the AI can also do the data scientist guys work, but not recently. It will take some time to do that. But yeah, one day it will replace.
So it's trying to update the AI level.
Yes. So please be up to date yourself along with this study with AI. AI in the sense what?
Artificial intelligence.
Yeah. So in those sectors also you try to correlate these things, because whatever we are doing right now, or any code that we are writing right now, that may be written by AI in future. So no need of the people. So the thing is, someone correctly said, AI is not replacing you. The person who is using AI is going to replace you. So if you are studying DS, study with DS with AI, with the help of AI, so that it is not going to replace you. You are going to use AI and take some well, because see, if you have calculator, why you need to go for calculating manually in the paper? That's the point here. You have the privilege to write the code, like whatever mathematical equation we are writing here, CDF and PDF. If some machine is able to write that, why will write the code separately? So please be up to date with the AI plus DS. Okay, that is one recent topic I can see here.
So Ashish, can I add something here?
Yeah,
Like,
please.
in another next 10 years, like when all this groundwork is done, automatically the human element will be eliminated.
No, but to run the machines, you need help, human help, right? If you don't tell a machine what to do after certain, like it will do the repetitive work after certain time. Then once that the feedback or the instruction is over, then what the machine will do? It will again
That can also
require.
be automated, Ashish. That instructions can also be automated.
Yeah, the instruction can be automated, but it will take so many years from now. It is not that we are talking right now or this years.
So like I'm giving it 10 years from now.
10 years from now, yeah, we'll see that. Okay, then again, that's why everyone in the globe is around. It's not about you and me, guys. Okay, like all over the world people are talking about this and they are not sure what is happening. So everyone is just started now to implementing chat gpt or word in their workplace, because you don't want to be left behind in this race. So what is going to happen, that is not in our hands, but we need to be up to date with the. So chat gpt. So I also requested the technical team from Google to, if you are giving any project to you, better, because I can see I have multiple projects where people started asking implement chat gpt, implement word. They don't need anything else now. Do it, implement chat gpt. Okay, so that project I requested them to, if any project which we can use chat gpt api. I'm not sure because those api are cost associated, so maybe we'll get some free usage. The quota is very limited for chat gpt. I'm not sure about word, but I requested them if they can make any project on this topic. It will be really helpful for everyone, whoever will do the project, including me. Okay.
Ashish, you can divide the batch, like half for this, half for that, so that we can get the best of both.
Yeah, so those are the management decisions. So I just requested them. I don't look like, if you can do, then it will be better for the people, because
And
this
this is
is
just a suggestion so that we can
Ah.
get results from both the things, right?
correct. So suggestions we can give to them, and that is up to them to implement. So but I have done my part, because I see from various couple of weeks before I'm seeing this discussion, uh, AI is being implemented at every sector. Even if you are non-technical also, you are going to use AI. And to be honest, the demand is so high, even if whatever we are learning and the people, that is not enough to fulfill that demand. So many requirement we have. So in terms of money and jobs, please don't worry. Eventually, if you have the knowledge, people reach out to you.
All I'm
Okay.
looking is for entry into this field, Ashish.
Yeah, correct. That's what you need to, and that's what that part you need to do once you do some projects, hands-on projects on your own. Like take the help, take the reference, and do some hands-on projects. Then I think you are good to say that, okay, I'm into this field now. I can solve few real-world problems using the techniques I have learned. Okay. So discussion apart, let's get back to our exponential distribution. Now here, this is PDF of exponential distribution. F of x is equal to lambda e to the power minus lambda x. What is the CDF? CDF will be 1 minus e to the power. You need not to remember this, okay? You need not to just see that this is f of x and this is, sorry, this is PDF and this is CDF. And CDF formula is what? 1 minus e to the power minus lambda t. Now, how to calculate CDF? We have seen this, okay? If we'll for any function, if we'll do the integration from minus infinity to any particular value, that will give you the CDF. So here in this formula, this part is changed with what? F of t means what? This. Now means if you will integrate this f of x with certain minus infinity to limit minus infinity to certain value, that will give you the CDF, and this will the value it will come 1 minus e to the power minus lambda t, where lambda is the rate parameter which is represents the average number of events per unit time. Okay, let's see the examples, okay, without delay. So see guys, if you see here, with increasing lambda, where is that graph? what is increasing lambda? Lambda is equal to 1.5 is greater than. You can see here, this blue color with higher lambda. Then bit lower is, so that means what? Lambda is deciding the nature of your curve and the shape of your curve here. Okay, and let's try to plot this. Okay, uniform distribution where we have simulating in NumPy. We'll do it. Okay, we'll do it. I'm not sure whether we'll be able to do today, but yeah, we'll try to do it. Now, one question for you guys to understand. For example, consider a website that receives an average of 10 visitors per second. Now, can you tell me what this means? This is lambda. Why? Average of 10 visitors per second. Inverse of time, right? Now, looking at these questions, you can say what?
Lambda.
Lambda is equal to 10. The time between visits follows an exponential distribution. See, in this question, it is already told you that your data is following an exponential distribution. And rate parameter is 10 here. And you can use this exponential distribution that we learned here to answer this question. What is the question? What is the probability that the next visitor will arrive in the next 5 seconds? Probability of the next visitor will arrive in the next 5 seconds. There you will use the CDA formula because it will be the cumulative data from the previous timestamp. So if you put this data in this formula, what? 1 minus e to the power minus lambda t. Now in lambda, you know this is 10. T is you are calculating for 5 seconds. So that means cumulative distribution function will tell you 1 minus e to the power minus 10 into 5. Whatever this value, that will be the what? The probability that the next visitor will come in next 5 seconds. I think I have calculated this one. 1 minus e to the power minus 50 is around 0.9932. That means what? The probability that the next visitor will arrive in the next 5 seconds is 99.33%. So this kind of question also you can correlate with your exponential distribution. Let me see. And what is the next question? What is the expected time between visits? What does this mean, guys? What is the question they're asking? Expected time means, you recollect that expectations? That means what? Average or mean. Mean, someone is asking about the mean. What is the mean of exponential distribution? 1 by lambda. We saw that, right? We told that if your data is following exponential distribution, this is mu is 1 by lambda, standard deviation is 1 by lambda. So here it is asking about the mean only. So how to calculate the mean? 1 by lambda, that is 0.1 minute, or you can say 6 seconds. Now this is all about your exponential distribution, guys. Okay, so two types: normal distribution we saw, exponential distribution we saw, how this looks like in terms of plot also we saw. Now third type of, this one is easier one. This is not a complex one, very easier one, because this is uniform. Uniform means what? The probability of every random variable. When I say random variable, that means what, guys? This x-axis, right? The probability of every random variable will be same. So that means if you plot this, you will look something like this. There is no deviation like this or this. Every probability is same. This is called uniform distribution. And the mathematical formula for this is what? F of x is equal to 1 by b minus a. B minus a means this extreme point I'm saying, a and b. 1 by b minus a. That is a constant value. That means every point you take from this a and b, the probability will be 1 by b minus a, constant. That's what this is called uniform distribution. Easiest one among the rest two. You know, to those complex mathematics are there. Just the probability will be same for each random variable. If that kind of data you have where the probability is same, that is called your what? Uniform distribution. Now the point is here, whatever we just now learned, we can do this using coding. You can call this distribution, you can call this, we'll see. Okay, let's, without explaining, better to show you. This is how it looks like. Okay, this is how it looks like. I show you, right? Uniform. So when these are the examples of that rolling a dice and all, just for to try to understand what is the uniform distribution. But you need to keep in mind, if there is a equal possibility or equal probability of for your every random variable in your data set, that type of distribution is called what? Uniform distribution. Okay, what we have next, I think sample and population we already discussed, guys, right? Sample versus population, we need not to discuss that again. Now the problem is not the problem actually, the main point is here, whatever we learned till now, where to apply that. Now I told you, if you recollect, in the initial I told you we have a larger set of data and we don't want to process those data. So that what we'll do, we'll take some samples, and if we are not showing me the tiger, show me the cat. That's what we are doing here. And when I draw this diagram of a big normal distribution and a smaller one, now if I want to take samples from this bigger distribution, we should look like something like this. That means what? Even if this is a small amount of data, it should, if you plot this, it should look like a normal distribution. But if I only choose data points from this region, will it look like this? So I have to make sure, if I am talking about the tiger here, the cat also should look like a tiger. I can't create another animal and I can say, okay, these are too similar. No, it should look like that, the sample. So if you are taking samples also from the population data, you need to make sure this is also following the same distribution. Or if you plot that, this will also look something like this. Now, how to do this? How to take a sample so that it will look like the tiger? There, the sampling techniques come into the picture. There are different sampling techniques are there, where you need to take sample from the population and it will be similar to the population distribution, so that you can analyze or you do your calculation or experimentation on that small sample data, and you can conclude about the population data or the whole data. So you need to understand some sampling techniques here to do the sampling. Okay, let's try to understand. So I can see people started leaving. Okay, maybe office timing. And today, like, lots of people are not.
Monday.
So guys, are you getting late? Because we have 10 minutes. I need to explain you the simulating in NumPy. It will take another 15 to 20 minutes. Do you have the time? Shall we continue? Okay.
Can we keep tomorrow, Ashish? Like,
okay, so I can see also people started leaving, but no risk, no risk. We can do, but we didn't cover this part today. Okay, no risk.
no, because Monday, you know how the traffic will be.
Okay, sure, guys, sure, no risk. According to your preference. So I'm not going to cover any new topic here. Sampling technique we'll see tomorrow. Okay. there are, let me give you, there are 4 sampling techniques, which is actually out of scope of this session. So whatever we are, like I am telling you, few of things is not there in the session, but I'm still telling you because these are basic things. And there are different sampling techniques, 4 sampling techniques, and these are mathematically proved techniques. That also I'm not going to prove in front of you. You may be asking like why we're doing this and how you know we need to do this. There is mathematical proof there in behind of this concept. If we'll follow these techniques. So here I am like in the tomorrow session, we are going to see two sampling. I mean, even in the case, if possible, I'll only show you one technique, the rest technique, because this is a bit, you need to understand this. And if you understand one technique, then other techniques you can refer other blogs and those concepts, and you can implement that, not a problem. But here these techniques are not mentioned in your sampling from continuous distribution. Only this is mentioned, but there are like couple of things. The most 4 used is this one, and there is mathematics behind it. That also I tried to show you here. This is the mathematical proof, which I'm not going to prove in front of you, because you will then you will get like, okay, we're not going to do this, because so many things are there mathematically. But I have provided those who are interested to see the proof in mathematics also. You have this YouTube videos I have provided, okay, in the more information section, no? Because I was trying to explain in one session and people started like, no, this is too much complex. So let's not do that. But yeah, those who wanted YouTube videos and all the documents, how this mathematically proof, what is rejection sampling, how this is mathematical proof, someone beautifully explained in this YouTube video I have already provided to you. If you want more, you can explore these things. But I am going to tell you tomorrow about one sampling technique, that is inverse sampling technique. Okay, let's not do it today because you guys are already telling that getting late. So if you want to proceed, you can go. Okay, and if you have any questions, those who want to ask, you can stay and ask.
Excuse me, sir, that you are saying have to do the project in Chat GPT like that.
Not I am telling, I am suggesting, I'm thinking it will be good.
Okay, we want to interested in that. For that, what we have to do and how to do that, sir?
See, that is still, I am also doing some, because I am also doing some project from some clients based on that, but that is cost associated. So if you want to use Chat GPT API, that is not free actually. You have to pay for that. That is also a big thing you need to keep in mind if you are planning to do this project. So you may get error like quota got finished. Okay, your usage quota got finished. So there is no free versions. That also you need to explore.
Okay, if that so means if we want to do the projects in the, you are also saying that when you do project, then only you have the clear idea and you have the confidence. I am also accepted and I want to do that now. And for that, what should I do, sir?
So first of all, you to specifically those who are starting like you, okay, please don't worry and don't be in a hurry. Okay, first you finish this concept, do small projects that is given. That YouTube API also very good one. That like if you'll do a YouTube API project using MongoDB and SQL, then only you proceed for Chat GPT API.
But in the Google side, they have not assigned anything, not yet. For me, it's not coming. I don't know. Other one who's receiving it or not, I don't know.
Sir, in Zentotal, syllabus is not parallel for what we are doing every day, sir. It's much more advanced.
That's what. That's what we are going very slow. That's why I'm telling you, no, from the starting.
Yes, sir.
So we are going very slow, and if I'll go quick, then you are going to scold me. I know you guys, okay? Because these concepts are like this.
This way only, then only we can able to understand and cope up with you.
So no, that what she said, that is a different context. She is saying like we are not covering what is assigned every day.
I didn't mean it, sir. Like I want to say that if it's updated means it will be easier for referring old videos. If any concept we didn't get it, means we
Yes,
can-
she is correct.
But-
Actually, we get confused when we want to see the session, recorded sessions. Topics will be different, and what we are learning will be different.
And assignments were also not parallel for what we are getting.
Yeah.
Actually, I'm not getting you. Can you share your screen and show me what you are telling?
Sir,
Show me what you are
in
telling.
Zen portal, we are not getting concepts what we are discussing in the class, sir. Can I?
So can you show me that one in the Gen portal so that I'll get a clear understanding? I got your point. I totally got your point, but 70 to 80% I got. I want to get it clearly because what I'm sensing, the portal topics that is shown to you is different that we are covering here in the class, right? That's what you're saying.
Can you see my screen, sir?
Yes.
1 second. Sir. Actually, today I was I
No
joined.
worries. No worries. You joined through mobile, right? No worries. Yeah.
Today we discussed
Uh-huh.
statistics, sir. Data visualization is on our syllabus.
Right.
And for, let's say for 11th class, we are getting no schema. This as a content that we play recording means that shows another topic. If it's updated, that will be easier for referring, sir. And assignments also can be parallel for what we are learning in that week. We are getting
No,
assignments in advance.
that MongoDB, that part, what is the problem in that MongoDB part?
No, sir. I'm just saying about
No,
the
sir. Actually, it is not coinciding with the dates. That's all. All the topics are you're teaching are same, but the topic you teached on session 22 is already shown in session 15. We are
already
can you understand?
session. Can you please stop sharing so that I'll share? Okay, I
Yeah.
got it. I got your point here.
Topics we are going slow, but it is normal only. But we are getting confusion with the display only, not with the topic.
Oh, okay. Got it. I got your point here. Sorry, because see, I'm not.
If it's updated, then it will be more comfortable to understand.
So can you tell me today's date, what is updated in your Gen portal for today's class?
For today's date,
It's data visualization, sir.
It's data visualization. And before to this one, prior to this one?
it was 21st.
Yes, sir. Today.
It is data visualization with a plotty dash. And for today's, it is second part, data visualization with plotty dash second part. Yesterday, 21st session is first part.
Hey, they're showing module 11 to you. We are at module.
Yes, exactly.
We are at module 8, right?
8. So
8, that also here.
Yeah.
So
when we want to see MongoDB session, we have to listen to all the recording, which is MongoDB session.
Okay, so see, that's how they designed. So actually, if you'll see from the starting, we are getting late. Okay, from the starting, at the day one, when I took the first session, there we have to complete this one. But we completed this one because also we have some introduction session there for 45 minutes, right? From there onwards.
No, that's not a problem. So easy. It's not with you to write all the details what we have done today. Like you are sharing the files every day, no, sir. Like that.
So do one thing. I think better you refer this document and any prior video that you want to see, you go to Gen portal and see those topics here, like this document. Suppose here you want to
that's
know,
the way I'm doing.
that you need to do, because there's another way, because they have designed in this way that one day you have to finish this topic.
Yeah.
But from the starting onwards, we started half and half, right? and it's also getting slower and slower. So that's why like one or
I
two
think we are
sessions behind.
6 days behind, 6 sessions.
Correct. And I think last Thursday there was a holiday, but I think they implemented that also. We didn't take
No,
any
sir.
class on that.
No. Last Thursday
Yes,
was
yes, you are
holiday.
correct. Ashish, we had break on Thursday, right?
Thursday we had a break, so they have popping up that part also. Because if I say data visualization is 2 module away,
Yeah.
lastly part you have to finish this one. So maybe they didn't consider the Thursday as a holiday. They keep updating the video.
We have to have a clear check with this all the modules, sir, because in case we might miss some assessment also.
Right.
Uh,
Let you guys also inform them. I'll also inform them today.
Yeah.
If anything they can do for this one, because we are
Actually,
going.
on 20th June itself, we have got the assessment link for probability and statistics with NumPy,
No, see, other
module 7
batches,
and 8.
why we are going too slow, because I can feel like you guys are interested and asking questions. If we
No,
do
it is not
yeah.
anything from your side, sir. It is from the management side. You are on the right speed.
No,
If we go,
that I understood. But usually what happens, no, people don't ask such this much questions and all. They like I felt like in weekend class, you like I struggle to get a question from people. Please ask. I study the same thing, same topics, but based on the people interest, no, the flow is decided, how the flow is. So I'm
yeah,
not complaining or something. It is a good thing that I'm saying about you, that you guys are interested. That's why we're getting slowed also. But that is a good thing. I struggle to make people speak. And to be honest with you, past 1-2 week, I am going through these modules, the statistical and probability. No question. People will stay silent. Like, what is this? Why am I learning this? Not sure. But yeah, as we progress, no, you will be interested. Okay, so this partly again, this is a development setup. Okay, development, you have to develop application using your IDE. This is going to be interesting. Handling missing data, very interesting topics are coming. Only this till this session 18, guys. Okay, till session 18, this hypothesis and all bit theoretical and probability. So tomorrow we'll finish this one, simulating in NumPy.
so will you be handling all the 22 sessions?
Not all. I think till module 14 or 13. I think till that part. Then we have other good mentors, okay, which will take care of this ML part. I can do that, but that will be not good for you. Like you need to explore different possibilities here. Like from different people, you'll understand differently. So all this starting part I will cover till module 13 or 14. Then the machine learning part, I think someone else will take. But that takes time. This is still there is time there. Let's see. Maybe this month we'll see. I'm not sure whether morning batch we have other mentors or not, because I can see. Let's see, guys. I'm not also sure that I can't tell you that I'm not going to take. Maybe and may not be. Okay. So, but yeah, let's continue. This is where you are going to get interesting things, because okay, sorry, module 10 and module 11, because here visualization will come. We'll plot the curves with code and all, and here we'll try to learn some development work. Okay, we'll create some application in Dash, a plotly setup, and you can create your own. And I think by now you should have got that project. I'm not sure why you're not getting. Have you
Have. Does
So-
anybody go?
anybody in this call got anything in the mail? You get it in the mail, guys, not in that portal. Mail. So keep okay, I'm not sure then. Let me first verify this problem that you're facing. But as of now, you refer this document and see the topics.
Yes, sir. You are update this one also, sir. Topics.
Okay. Let's then see tomorrow, guys, about this one. And any other questions or any doubt or anything that you have? Sir, the project will be appointed when? Rishikesh. I'm not sure, to be honest with you. That is up to them how, because all, other batches are already getting it there in mail. But I'm not sure about you because yours MongoDB is also over. Now you are in the probability and statistics part. So by now you should have got that. I'm not sure. Or is it different for morning batch? I'm also that. Let me spoke to them. But what, keep one thing in mind. Once you get the project, no, you will get super VJ. Okay, the super VJ in the sense you have to spend some time on that project. If you don't give, no benefit at all. So you have to if you're starting from the scratch, those who have some coding understanding, I think that will be easy for them to grasp. But the people who are starting from the scratch, you have to give 1.5 hours for that particular project apart from our session. Okay, that also you need to keep in mind.
Already we are spending.
Yeah, no, you are spending here, but for that particular project, you have to spend separate time.
Yeah.
That's what I'm saying.
Actually, thing is, if we leave what with the sessions itself, next day we will be blank. After the sessions are finished, another we have to spend another 1 hour or 2 hours in recollecting the things and going with the flow.
Okay. Then I can imagine. So apart from that, okay, this session plus your exploration session plus another 1.5 hour.
Yeah.
Okay, guys. So that will be super VG. And but that benefit you are going to get, that is for sure. That I am sure. Okay, so let's see. So you are asking for project and project. I know once the project will come, you guys will feel that. Okay, so let's see. I am here to help you out how, like, all the possible ways that I have. Let's see.
So, thank you.
Okay, okay. Then see you tomorrow, guys.
Yeah, so thank you. Have a nice day.
Yeah, yeah. Bye, guys.
Thank you, sir.